All right, no questions via email, so I'm here in the chat in case you got any questions. Otherwise, I'm going to sit here and work on the banjo for a while. Yes, you need to list the physical properties of the reagents and the products for the reaction because they are relevant to the final analysis. It tells you what physical properties you need to have in that, so you need to go to the depth that's requested in the lab introduction. Yeah, it's mostly because, especially if you look at what's being asked of for the post-lab analysis, you need that information. So that information is going to be very relevant to discussing the final parts of the lab, which you have to do before you leave today. So yeah, it's not an exercise in futility. Like, it's information that you need to decide based on what you measure at the end. If you were able to isolate the desired, if you made and you isolated the desired product. So discussion board for 252. Hey, a real question. So it's asking about which molecule would give the Hayworth projection that's seen on the right side. So let me bring up that discussion board. So the starting Fisher projection that you're given, oh, actually that's stuff on board too. There you are. You're asked which of the compounds that are drawn 1, 2, 3, 4 could be a potential candidate for the Hayworth projection. Now, the thing to keep in mind with this is that we can have, when we make this ring and when we attack with this OH group onto this carbonyl, sorry, this group here, really this can be above or below the ring. The OHs here are the big thing. So here, all 3 OH groups are on the same side. And I'm going to have to blow up on my monitor. So I'm going to share my desktop with you here for just a minute. There's only one of these that has all the OHs on the same group, and this is group D. Now, this methyl group here, this CH2OH group here, it can be above or below because we're going to form an OH group with this oxygen from the carbonyl. But because this is a trigonoplanar molecule, we can have a situation where the OH group goes up and this CH2OH group goes down, or we can have the OH group down and the CH2OH group go up. So the only one here that really works for the Hayworth projection is compound D. So D can be made from this compound on the right. But yeah, the tip-off on how to answer this one was just simply looking at the fact that we have all 3 OH groups on the same side. That also has to be true in the Hayworth projection as well. So the question is, I see, is there any chance that the carbon that contains 2 hydrogens would instead have an OH below the ring and a hydrogen above? It's that more that cis-trans has, if OH groups are cis relative to each other, trans relative to each other, that also has to be true in the Hayworth projection. So I'm not quite sure how to answer your question in that regard. If it is a CH2 group, is there any chance that the carbon that contains 2 hydrogens would instead have an OH group below the ring and hydrogen above? So if you're asking about could you take that CH2OH group and put it underneath the ring and then move the OH group up? So let me bring back up that image. So if you're asking, can this OH group and this group flip? Yes. Because this oxygen here, that's this oxygen attacking on the bottom right, it can attack from above the ring or below the ring, and in doing so, it'll drive the carbonyl group either up, it'll drive that carbonyl oxygen either up or down. So there's actually two possibilities here, the alpha and the beta forms. And I think this is the alpha form that's drawn here. But yeah, you could definitely have a situation where the OH group goes on top. How it is in the PowerPoint. Oh, you're asking a different question. Let me open the PowerPoint. Review of Fisher projections, review of don't suppose you have a slide 33, thank you. Okay, so the one on the left is an aldose. For a so if you had an aldose, you could definitely have a carbon that had the two hydrogens on it. Because this is a ketose, that's why you end up with the image that's on the right. So the difference between the left figure and the right figure, I guess I could actually show that for people to see. So in this one, the figure on the left is an aldose, and that's why you end up with the carbon with the two hydrogens. It's actually that carbon there. And for the ketose, get a feeling that's supposed to be an H there, not an OH group there. Yeah, I'm thinking the two hydrogen, that's actually a typo in this slide. That should be an H and an H there from that carbon. And that ring is actually drawn backwards. Definitely not my wheelhouse when it comes to like working with aldoses and ketoses. But yeah, for the aldoses, you'll end up with, yeah, I see your confusion now. Yeah, I think those are typos on that slide. And now you got me worried there's a typo on that. On that discussion board. Oh, thank goodness, that's actually done correctly. Okay, so the discussion board is correct. The notes, there's just a mistake. There's a CH2 group missing from the ketose on the right figure. Yeah, I'll just correct that in future versions of the slide, future versions of those slides. You're welcome. Yeah, I'm looking at your discussion board for next week. Is like, I kind of know how to answer that one. I sort of know what those words mean. I'm like to page 300 at this point. I'm finally to the point where the Harkonnens have like taken over. And I'm so glad because it was getting so laborious. But yes, I'm finally to the interesting part of the book. Not to say it's a bad or poorly written book. Like, I like the intrigue, but it's like I've also kind of seen the movie, so I know what's happening. I'm like, come on, just attack already. And I like the book, but I am going to harp on how like every chapter has to remind you that he's the Messiah. Like, it just has to come up at some point in every chapter, and it's so nice that we can finally get that past us and just kind of get to it. But yes, overall, I'm really liking it. 300 pages in. Actually, it's 700 pages total in my version. I forgot the back 100 pages were like nothing but appendices. But I'm like almost to the halfway mark. Yeah, like every chapter, you could like make a bingo card. I was like, by the way, Paul's the Messiah. In case you forgot, he's the Messiah. And here's a whole bunch of like weird things to remind you about it. I am thinking about getting the next book in the sequel series. I think it's Dune Messiah, seeing how that goes. I am curious about the Dune movie that they're making. I'm a little worried because there's a lot of A-list actors and safe bet actors and actresses in it. Um, that's usually a bad sign for a movie, but we'll see. At least the trailers look good, right? Yeah, it's. I can see the love of the book. Like, there's clearly a bigger universe that's being really well fleshed out in the opening chapters. It's one of those books that just takes a little while to get going. Once it gets going, it's pretty good. If you're really looking for a book like akin to like just beautiful for the sake of wordsmithing, I would really recommend reading Hyperion. That is a book I think is really a beautiful example of how the English language can be beautiful and how it can be really well done. Basically, nothing happens for most of the book. You're just hearing the lives of the five people that are on a pilgrimage. But the stories are so good. They're like five different literary styles as they tell their stories. So one's kind of like a crime film noir, one's kind of this really nice epic science fiction story. Um, so that I think is a very good science fiction novel. And even the sequel, as much as one of the main characters is really great on me, I still think the sequel, The Fall of Hyperion, was worth reading. I would definitely not recommend reading Endymion and Rise of Endymion, which were the two sequels to. Um, Technically, Hyperion and Fall of Hyperion were just two of the same book split into two. Same thing with Endymion. Hyperion series, totally read. Endymion, do not read that series. It will just crush any high regard you had for the original books. And they get really creepy when you realize the author's backstory. I think there were 4 books that were originally written by Frank Herbert. So Messiah, Dune, Dune Messiah, Children of Dune, and okay, this is bothering me. What were the books in the series? Dune, Dune Messiah, Children of Dune, God Emperor of Dune, Heretics of Dune, and then Chapter House of Dune. Let's look at the other land. I read, who was the author? Who wrote Neuromancer, and there were 2 sequels to it. And I read those. Neuromancer I thought was good for the Cyberpunk series, but it definitely shows its age, and so do the sequels. But I would say they're worth reading. You're going to love Hyperion. It is just a beautifully written book. Again, kind of why the last 2 books in the series were such a disappointment. They're not nearly written on that level. Like, there's a lot of setting, there's a lot of payoff, there's a lot of ambiguity, and with the last 2 books, he kind of had to retcon because he really wrote himself into a corner. What was the one I more recently read? Yeah, you're going to really like Hyperion. Oh, I got him right here. The Hitchhiker's Guide to the Galaxy series. That I was kind of disappointed in. I liked the first book, but I understand the lovers of that book series. I could not get into any of the sequels. They had their moments, but there were some that I just thought were just kind of dumb. Like, they just didn't go anywhere. Maybe that was the point of the novel, but the first one went somewhere. Things happened. But I've got 4 of them here: Hitchhiker's Guide to the Galaxy, So Long and Thanks for All the Fish, The Restaurant at the End of the Universe, Life, the Universe, and Everything. And by the time I got to the 4th book, I just couldn't. I couldn't do it anymore. I couldn't read Mostly Harmless. There is a movie that came out in the 2000s with Alan Rickman for Hitchhiker's Guide to the Galaxy. That movie is amazing. Alan Rickman as um, starts with him, the robot that was like constantly having an existential crisis. Pitch perfect casting. And Martin Freeman as the main character. It's a movie really worth seeing. It's a shame it never took off. I think it was a combination of Hitchhiker's Guide to the Galaxy, and there were a couple of other little novels sprinkled in there. I totally get it's kind of an esoteric movie, but I think it really does kind of capture the weirdness of the book, but in a good way. Oh, just so I don't forget to tell y'all, or so you don't miss it, we are trying to open up a third section of 252 Orgo 2. It will be Fridays at 8 a.m. tentatively. We've submitted to the registrar office. It'll be on Southern Wake campus with me. So for those of you who are like trying to get in through the wait list, and you've noticed it's like 6 people deep right now for 252, there will be a Friday section opening up. Now, if you want me to let you know, I can send you an email when I find out. But I'm going to be honest with you, they don't tell us when new sections open up. We generally find out when we go to check Blackboard and notice suddenly there's a new section sitting in our side of Blackboard. So my best advice right now is just kind of camp out on the registrar's office. I know it's been requested today. It will probably be tomorrow if it shows up at the earliest. More than likely Monday or Tuesday. We're most likely going to be able to get approval for this section because I am waitlisted like 12 students deep if you combine the two sections. So if you weren't able to get into 252 in the spring, again, there is going to be a Friday at 8 a.m. section that's opening up. Yeah, and Orgo 2 is actually easier than Orgo 1, especially if you have a really good foundation in Orgo 1. So we'll be making things like cinnamon extract, perfume extracts, food additives, things like that. So just saying, Orgo 2 is a lot more synthesis. So with what you do for the practical, you're getting a much better flavor of what you kind of do on a weekly basis with Orgo 2. And it's very much a let's make this week, let's make this week, let's make this week. And you start seeing what actually, if you ever take Organic 3, basically that's all you do in Organic 3 is synthesis. And if you have a good instructor, you generally do some really kind of cool syntheses that make some pretty cool compounds. My magna opus, the one I really want to see if I can make happen, is converting capsaicin, which is the hot ingredient in peppers, to vanillin. And the synthesis I've got written out, it looks like it could work. I've talked to a lot of people. The problem is like getting your hands on like pure capsaicin. So ideally with this lab, you would do an extraction to get the capsaicin out, isolate it, and then convert the capsaicin to vanillin. You'd smell that conversion because capsaicin doesn't really have a smell, and you'd smell it convert to vanillin. And as instructors, we think it would also be kind of awesome because the students that are really like laissez-faire and lackadaisical about doing safety equipment, they're going to know, you're going to know fast who is not paying attention to the safety instructions, because working with pure raw capsaicin will definitely leave burns on your skin. And there's not much in the lab you can use to get that off. So it would be an awesome lab if I could get up and running, but I got to get a hold of the pure capsaicin first, and there's like a lot of steps between here and there. But that is a lab I'm like constantly like looking at and trying to figure out. I tried to do the extraction. My habanero peppers didn't have enough capsaicin in the seeds to really produce enough to measure anything. So I think it's going to be one of those I have to work with ghost peppers, or more than likely just order a bottle of capsaicin. But yeah, you should totally go take 252. And it's not just because we're trying to drive up demand for our organic courses and justify opening more on more campuses. It's actually, in my opinion, the labs are more fun. Because with Orgo 1, like we do have to lay that foundation. Like you need to learn how to do a TLC, you need to learn how to work with a SEP funnel, you need to learn how to run distillation, and you need to learn how to like characterize the materials when you're done. That's just a hard fact of life. But the idea is that it's all kind of front-loaded in Orgo 1 with a couple of synthesis labs at the end to frame it all. And then you hit Orgo 2, and it's like, okay, there is one lab where we have to go through, like, okay, here's how you test for an aldehyde, a ketone, different types of alcohols, because they are relevant to proving your final product. But a lot of the labs are coming in. You're working with compounds. The lab I'm trying to develop for the fall of next year is you work with an alcohol and a ketone, and you convert them between each other, but they're both food additives, so you're going to smell the conversion. When one converts to the other, you're going to smell it. And we also make what was supposed to be the practical, and that was kind of the artifact you saw in the practical with acetic acid. You're going to make butyl acetate, which is, okay, people claim it smells like apples. It smells like nail polish cleaner. I don't care what anyone says. But you're going to make it from two compounds. One smells like vinegar, and one is in butanol, which really doesn't have a smell. So you're going to take two things that don't smell anything like nail polish cleaner and convert them into nail polish cleaner. And that's more where organic chemistry, for me, that's where the interest comes, is the synthesis. And pretty much that's all organic chemists do in their graduate careers, is just synthesize things. How do you make these compounds? How do you convert one thing to the other? And ideally, we'd have other labs that would focus on specialized syntheses. We're going to try a Grenier lab this spring. We're going to see how well it goes. It's kind of what I'm messing around with in the labs right now, trying to get to work. Almost got to the point where I'm making benzoic acid. I actually isolated some today. But Grignards are not particularly, we talk about them a lot in Orgo 2. They're not useful. They're not done industrially, but you can do some cool things with them. So at a minimum, get you exposed to also some of the more esoteric techniques in organic as well. And then if you ever go take Orgo 3 and you have a good instructor, then you'll start synthesizing some like really weird and crazy things. Yeah, chem is one of those, like, I'm not trash on biology. I just haven't done biology since high school. Um, but I just enjoy synthetic chemistry. From the background, my background has fields, but if you're curious why I crossed so many fields in my thesis work, it's because it was synthesis, synthesized nanoparticles, synthesized different compounds. I had to make a catalyst that was isotopically labeled, and it took like 20 steps to get there, and it was pathetic yields, but 20 steps you expect pathetic yields. But it's kind of awesome when you spend 2 weeks doing something, isolating something, at the very end you get these tiny crystals that are worth about $10,000 because you've made it from scratch. And we know it's worth $10,000 because that was the quote we got from the company, and they said for $10,000 we can make this compound for you. And we said, well, graduate time is effectively worth nothing, so I guess for 2 weeks I'll be sitting in the lab with about $100 worth of chemicals to make a $10,000 product. So for me, the fun part of chemistry is the synthesis and the characterization. Like, the theory, it's cute. I'm sure people really enjoy it. But synthesizing things and figuring out if you made them, that's the cool part. All right, so I'm going to go ahead and sign out. I do need to take care of a few things. So Orgo 2 folks, I will see you in about an hour. You're doing the same practicals as Orgo 1 students. I'm sure they have lots of positive things to say about it. All right, there are 2 more live streams left for this semester, one tomorrow and one for Monday. So I will see some of you tomorrow. Thanks for showing up.